So with that, let's move on to number 6. So for number 6, we have write the electron configuration for P and Cl using spdf and orbital box. And then they want us to describe the relationship between the electron configuration and its position on the periodic table. So let's start right away by doing the electron configuration first. So we want to make sure we do our whole off-ball principle, the 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f. And I want to stop there, even though I could just keep listening to the whole thing, just because based on our periodic table, as soon as it loads, phosphorus and chlorine don't go actually that far. They actually end in the 3rd row, so we don't really have to go that extensively. With that being said, though, in regards to S, P, D, and F, if you look at the periodic table, if I just drew that like that, yeah, I've gotten pretty good at drawing a periodic table. Your first and second rows, which is going to be right here, this is known as your S orbital, and that is going to be indicated by just 2 electrons in that orbital, and you'll see because it only has first and second column. The one thing is that helium also counts as an S, so that would be kind of like the exception there, something you have to watch out for. The P orbital is going to be right here from like rows 13 through 18, not including helium. And as you can see here, when you count, we have 6 electrons there, so it's going to be in a total of 3 orbitals, because 2 electrons per orbital. So the S orbital only has 1 and the P orbital has 3, and because each of them can fit 2 electrons, we know 2 electrons are in S and 6 are in P. And then for the D orbital here, which we won't cover for this question, but just as a reference, it's going to be between columns 3 and 12, and that would be 10 electrons or 5 orbitals, and you can count actually through the periodic table. And then F, which we also aren't using, is going to be a lanthanium and actinium series, and that one, it's going to be a total of 14 electrons, which means you have 7 different orbitals in F. With that being said, the cool thing is that the reason why I mentioned that is because we pretty much just count through, and we have to make sure that we're referring to the right orbital. So hydrogen will be 1s1, helium will be 1s2. So for both chlorine and phosphorus, okay, we so far have 1s2. So for both phosphorus and chlorine. And so now we jump to the next row. We have lithium beryllium, that would be your 2s2. And then we have boron through neon. Remember, now that we're in our p orbital, that's 6 of them, so that's 2p6. So we've crossed this, and then we jump down to sodium magnesium, that would be 3s2. So we can cross that out. And now we're actually aluminum, silicon, phosphorus. So if we count it out, that's 3. So that's 3p3 for phosphorus, and chlorine just 2 more ahead of that, 3p5. Okay, so these are the electron configuration using the S, P, D, and F. And in order to the orbital box for phosphorus, so we have, as I mentioned, S is 1, P is 3, and this one only went down to the third shell, because that's the 3rd row. So Cl, same thing as well. 1, 2, 3, 4, because this would be your S, and these are your P orbitals. Okay. And now that we've done it like that, what's going to happen here is that as we fill in, as we said, it was 1s2, so we have like that, 2s2, and then 2p6, 2, 3, 4, 5, 6, and then 3s2, and then 3p3. So we have 1, 2, 3. So as you can see here, orbitals get filled halfway first, like one in each, and then it goes back and fills in again. And chlorine, the same thing here. 1, 2, 3, 4, 5, 6. And so we have 1, 2, 3, 4, 5. So now we have both the orbital box notation for phosphorus and chlorine here, okay? And now the last question they ask is, what's the significance between this and its position in the periodic table? So this can actually be found through the superscripts of your full electron configuration. We have 2, 2, 6, 2, 3. If you added those numbers up, you'd actually get the element number for phosphorus. So 2 plus 2 plus 6 is 10, plus 2 plus 3, so it's 15 electrons we're dealing with, and phosphorus is indeed the 15th element. Because if you remember, elements are typically determined by the amount of protons they have, and if you have a certain amount of protons, as long as you're not dealing with ions, you would have the same amount of electrons, hence why it tells you where you are on the periodic table. Chlorine, on the other hand, you have 10 and then up to 17. So we have 17, and chlorine is indeed the 17th element on the periodic table. So that is how they relate. So let's see how we did. Yep, 3p3, and that's how they fill it halfway. It's perfect. And chlorine, 3p5, and that's how they filled it as well. Great. And exactly, they group 15 in periodic table, group 17, and it has 7 electrons in its third shell. Pretty much exactly, you should be able to, in a sense, find exactly what element it is, and based on the amount of electrons it has, as long as it's not an ion you're working with. So let's move on to question number 7.